ओके सो वेलकम बैक टू माय चैनल। सो मैं ऑब्वियसली मेरे क्लाउड एआई पे काम कर रहा था, मतलब क्लाउड एआई नहीं, मेरा खुद का एआई जो कि क्लाउड जैसे काम करे। तो ये मेरा खुद का एआई है। देखो भाई, सिंपल चीज़ है, इस पर हाई लिख के भेजो तो सिंपल हाई आएगा, ठीक है। और इसमें ये चीज़ काम करती थी, अभी पता नहीं क्यों नहीं कर रही। मतलब काम अच्छा खासा चल रहा है इस पर, ठीक है। और ये हिस्ट्री वगैरह सेव करके रखता है, डिलीट वगैरह करता है, सिंपल काम था। लेकिन अब ये बनाते बनाते सेम इसी चीज़ से मेरे को एक आइडिया आया कि मैं इसी चीज़ से मेरा खुद का एक टॉपिक बनाता हूँ, या और फिर टॉपिक में मैंने देखा कि मेरे को एक 5G रिलेटेड कुछ देखना चाहिए, है ना। तो वहाँ पे मैंने क्या किया कि मैंने इसी से एक प्रॉपर सोल्यूशन क्रिएट किया है। ऑब्वियसली मैंने मेरा खुद का भी दिमाग लगाया, मैंने खुद का एक प्रोटोकॉल भी यूज़ किया वहाँ पे। ऑब्वियसली मेरा खुद का प्रोटोकॉल था वो, ठीक है। सो अब मैं आपको प्रेजेंट करता हूँ वो। मैं बहुत ही ज़्यादा स्पीड में बोलूँगा क्योंकि मेरी आदत है, इसीलिए। तो चालू करते। और ये रहा मेरा प्रपोजल, ठीक है। सो आई विल स्टार्ट इट। So this solution is created for 5G Innovation Hackathon 2026, and you can see this is my proposal ID, which is JSRC ETC 5G04. So this is necessary for licensing. Okay, now the first thing. Wait a minute. Okay, that is okay. Okay, so the first thing. 2 मिनट में ये वाइप ऑफ। हाँ, अभी ठीक है, फिर से शुरू कर दे। Okay, so this is the solution for the problem statement given by the 5G Innovation Hackathon, which is a national level hackathon conducted in 2026. So our solution is AI driven cell-free massive MIMO with productivity network encoding for a 5G advanced URLLC. So what is it? It is estimating rate transmission glitters and cell edging degradation for mission critical systems. So my name is Deshpande. I am from ETC department from GHR College of Engineering, and this is the theme of problem statement, which is 5G advanced infrastructure for industrial IoT reliability. So let's start with the executive summary. This is just a solution, sorry, this is just a purpose solution. It is not a proper detailed research paper. So let's start with the executive summary. This technical approach outlines a transformative framework for ultra reliable low latency communication URLLC in 5G advanced network. While standard 5G achieves significant peaks throughput, its performance collapse in cell edge. Means the performance of 5G can be collapsed in a cell edge. What is a cell edge? Cell edge is a area where you can not have a 256 QM signals. What is 256 QM? We will see further. So in such scenario, due to the inter-cell interference and reactivity nature of the hybrid automatic repeat request, which is HARQ, it is just like AKC, which is acknowledgement bit. It is just like that, but for the 5G communication protocol. So our innovation is to provide a productive reliability layer through a dual punch approach. So the first is physical plane. Here we have to change the physical structure. So a cell-free massive MIMO architecture that dissolves cell boundaries to a productive in uniform signal stability. I will explain this in our further explanation. So the second thing is a logical plane. This is a logical uh, architecture where a predictive network encoding combined with semantic AI decoder. This is used to mathematically reconstruct the data instantly and bypassing the need of rate transmission, or you can say retransmission, because retransmission is directly proportional to the rate transmission. That's why. So this architecture targets sub 1 millisecond latency and 99.999% reliability, essential for autonomous robotics and real-time EV diagnostic, and also for smart industrial grade and any industry which use a 5G network. Now, current 5G technical bottleneck. So there are two bottlenecks I'm going to explain. First is the cell edge fading problem. Current cellular grids suffer from edge effect. User equipment, that is UE, move away from the tower. The SINR, that is I don't know what is it. SINR. Let's find what is SINR. I think it is a serial ratio of noise, sorry, serial noise ratio, like that. Let us see. So I have created all of this on my own AI. Yes, signal to interference plus noise ratio. I'm technically right about the SINR. Okay. So SINR is nothing but a ratio of noise dropped in a signal. So the SNR drops, forcing the network to down modulate from 256 QAM to QPSK. So you just imagine if you have a 8 channel, 256 QAM use a 8 channel and QPSK use only 4 channel. So which will be have a wide bandwidth. 8 channel modulator or a 4 channel modulator? Obviously a 8 channel modulator. That's why 5G is much faster, but it is not reachable, or you can say the wavelength of 5G is not uh, easy to penetrate anything. Okay, it doesn't have a property to penetrate a wall easily. I'm saying easily. Okay, as it goes, the energy is lost very effectively in 5G networking. So this result in unpredictable glitters and packet loss, which is lethal for real time control system. Nowadays everything is work on control system, that's why it is lethal. Now, reactive latency, this is the second problem. HARQ bottleneck, this is the last bit at the decoder side of a UE, which knows that if the data is corrupted or not, or if the data is received or not. Okay, so I will tell you the HARQ in this. Now, a standard 5G is reactive. When a packet is corrupted, the system stops to send a NAC, which is negative acknowledgement bit, and waits for the retransmission. This cycle adds 10 to 15 millisecond of lag. It can be easily visible if you are doing a stock trade. Okay, in a high-speed industrial environment, this delay causes synchronization failure. To fix this, what we have to do? We have passed our proposal. So proposed system architecture. First is self-free distribution infrastructure. We propose a shift from centralized macros cells to distributed cluster of access point, which is APS. Now, in our architecture, multiple APS servers are serves as a single user. So what will happen here? Instead of a single tower transmitting data to every user, what will we do? We will use n number of access point. So n number of access point can give or transmit data to a single user. If just imagine if there is a single tree which is giving fruit to n number of human, is this good? Or there are n number of tree who are giving food to a single human? Obviously the option 2 is more logical, or you can say, okay, we will go to the proposal. This ensures that the user is always in the center of the service area, effectively maintaining high order modulation, that is 256 QAM across the entire geography. You can see here instant the current 5G technology used a single transmitter. So what we have done, we have simply broken that transmitter into different types of access points. That's the single solution that we are going to give for our hackathon in a physical layer. Now let's go to the logical layer, that is predictive network coding. This is my first favorite because I have made my own protocol using this same logic. This logic is my own and it is original. So this idea is original, about is also original, but I don't know, I didn't research on that topic yet, but this idea is my original idea. So let's look out to this. To achieve zero lag, we place the we replace the HARQ cycle with productive matrix based network coding. Before transmitting data D is transformed into a reductant coded word C using a generator matrix D. C equals to G into D. Okay, now if a packet are lost, the receiver does not request to resend. Instead, it solves the system of a linear equation to reconstruct the original data D. You can see D equals to G dash minus 1 into C received. G dash minus 1 can be very on the basis of the corruption of the data. So you can see this is the simple block diagram. You can understand it. It shows that productive error correction flowing bypassing HAR retransmission cycle. Now the third and last, the master system integration. Our master architecture integrate the 5G core with AI enabled edge layer. The semantic AI decoder meal model, which is again a protocol like CAN, which is used in a space industry. So I have taken some idea from that and I have used that idea in this model. It sits at the networking edge. Now it monitors telemetric pattern. If the channel becomes extremely noisy, the AI predicts the most likely bit sequential based on the previous application behavior, that is semantic context, and then prevent control loop interruption. Again, there is a diagram. You can see there is a feedback loop, and based on that, MIMOs give the transmission. Now, impact and performance, which is necessary, because why we are doing this, there has to be an impact and there has to be a benchmark performance. It is just by the it is just come through the calculation. It is not come to a practical version, but calculations are also needed for the practical version. So let's see. E to E latency. Standard 5G gives 10 milliseconds to 25 milliseconds, but our proposal reduced this to less than 1.0 millisecond, which can improve the reduction in latency up to 90%. Second, reliability. Current 5G standard give 99.9% reliability, but our proposed solution give us 99.9999%. In IoT and a control system industries, this is a big difference. Okay, this is a mission critical grade improvement. Third, modulation state. Variable SINR, which is noise ratio, dependent, but in our it is independent because of n number of access point. There is a stable 256 QAM, which is 3x stable as compared to standard 5G. Now, last but not least, that is error handling. The old, or you can say the standard 5G used reactive analyzing, which is HARQ, but we are using a productive error handling, which is matrix AI. It is instantaneous because HARQ requires a tower to send the data again if there is an error, but our solution does not send the data to the tower that I have received corrupted or a wrong data. Instead of that, it do the calculation and identify what is the corrupted data, and based on that we will have the simple corrected data. Then a URLLC mission critical loop. This is the whole purpose that we have understand these three different layers. Now we will combine this, and you can see a primary goal of a framework is that end-to-end mission critical loop. By ensuring the feedback from the application plane reach the core plane in sub 1 millisecond, we enable a new class to tactile internet application. You can see we combined all three loop here. Now, target industry use cases: autonomous collaborative robotics, ensuring safe human robot interaction in high density smart factories without rate transmission spikes. Then EV diagnostic telemetry and rural remote connectivity. And finally, the conclusion. The purpose AI driven URLLC framework is a 5G advanced solution designed to transform the network from best effort service into a mission critical utility. By dissolving cellular boundaries with cell free MIMOs and solving the latency bottleneck with matrix based AI, we provide the infrastructure required for the next generation of India autonomous and industrial sector. So that's my solution for current problem in 5G networking, and I have generated this by my own brainstorming abilities and from my own created AI. So thanks for watching this stream. If you like my video, just subscribe the channel because it can give me some type of motivation to make such type of solution which can be good enough for me or good enough for you if someone is watching and want to invest in such solutions. So that's all for today. I will meet you again in a next stream where I will work on my AI, because this is just the initial model. I have to make it advanced level like Claude or ChatGPT. So till then, bye bye. See you later.